Welcome to This Explainer. Today, we're pulling back the curtain on one of the most absolutely crucial yet somehow constantly overlooked areas of modern data science. We are diving deep into the vital process of data cleaning, and we're going to discover exactly why it's the true foundation of trustworthy algorithms. So if you've ever wondered how just raw, chaotic information gets scrubbed and evaluated to become a reliable engine for decision-making, well, you are definitely in the right place. Let's get right into it.
Okay, so here's our roadmap for today. We are kicking things off with the dirty data problem, then we'll clear up the confusion between cleaning versus transformation, and finally, we'll walk through a solid 3-step template, removing unwanted information, fixing structural errors, and filtering outliers. All right, Section 1, the dirty data problem, or, why algorithms fail. We honestly see this all the time in business intelligence. A team builds this brilliant, highly sophisticated algorithm, but the results it spits out, completely unreliable. So we really have to ask ourselves, why do these seemingly perfect algorithms fail? Well, the answer almost always points away from the math and directly toward the quality of the data itself. It's literally the classic garbage in, garbage out scenario.
Think about what happens when we combine multiple data sources. Say you're pulling customer records from your marketing software and mixing it with your sales database. Right there, you introduce just numerous chances for data duplication and mislabeling. Even if your predictive model is totally flawless, if it's feeding on incorrect, tangled data, it renders the outcomes and the algorithms entirely untrustworthy.
And that brings us to our core solution here, data cleaning. Simply put, this is the crucial process of stripping away the inaccurate, corrupted, improperly formatted, duplicate, or just insufficient data from your dataset. It's essentially the defensive shield that protects your analysis from being completely compromised by bad inputs. Moving on to Section 2, cleaning versus transformation. Let's clear up some major confusion here. Before we get into the actual steps, we really need to clear up a very common industry mix-up. People use these terms interchangeably all the time, but they are totally distinct phases. Cleaning is strictly about removing the irrelevant data from a dataset. It's about taking things away. Transformation, on the other hand, which you'll often hear playfully called data wrangling or data munging, is about changing that raw data from one format or structure to another so it can be warehoused and analyzed. Basically, you clean the data first and then you munge it. All right, Section 3, Step 1, removing unwanted information. We're talking duplicates and irrelevance. Now, because there isn't just one single definitive method for every dataset out there, it is so essential to build a reliable template for yourself. Here is a bird's eye view of the 3-part data cleaning process we're about to tackle: removing the unwanted, fixing the structure, and filtering the outliers. Sticking to these 3 steps ensures you are consistently doing the basics right, no matter what crazy data set you're handed. So Step 1 attacks 2 main culprits. First up, duplicate observations. These almost always pop up during data collection. When you merge data sets from numerous sites, scrape data from the web, or pull reports from multiple departments, you are definitely going to get duplicates. Deduplication is paramount. The second culprit, irrelevant observations. These are data points that might be perfectly accurate on their own, but they just do not pertain to the specific topic you're attempting to study. To put that into perspective, let's say your goal is to study the buying habits of millennial clients, but your data set contains thousands of observations pertaining to earlier generations. Well, those older records are completely useless for this specific analysis. They aren't wrong, but they just create statistical noise and distractions from your core objective. By excluding them, your data set becomes so much more effective and manageable. Which brings us to Section 4, Step 2, fixing structural errors like typos and capitalization. Moving right along to Step 2, we have to fix structural errors. These are those really frustrating human and system errors that just naturally happen when measuring or transferring data. We're talking unusual naming standards, simple keyboard typos, wrong capitalization, or mislabeled classes. Now, a human reading a spreadsheet might easily know what was intended, but remember, an analytics algorithm is incredibly literal. To a computer, a typo or a lowercase letter can easily create entirely mislabeled and separated classes in your dataset. For example, you might have NA typed in one column and not applicable typed out in another. Obviously, we know those mean the exact same thing, but if you don't fix this structural inconsistency, your algorithm treats them as 2 completely different categories. They desperately need to be grouped together and examined as a single category so they don't skew your results.
All right, section 5, step 3, filtering unwanted outliers and really validating those numbers.
Finally, we hit the third step of our cleaning template, filtering unwanted outliers. This is where we confront observations that, at first glance, just do not appear to fit inside our evaluated data. And look, when you see a data point that is wildly outside the norm, it's so tempting to just delete it and move on. But we really have to pause and ask, is an outlier automatically an error? Well, it requires some careful evaluation. Yes, you absolutely should eliminate an outlier if there is a valid cause to do so, like a clear case of erroneous data input. However, do not assume that just because an outlier exists, it's erroneous. Actually, sometimes the arrival of a massive outlier will end up proving the very notion you're working on. So, the absolutely crucial takeaway here is this. You should consider deleting an outlier only if it appears to be completely unrelated to your analysis or if you can confirm it is a genuine error. Otherwise, it belongs in your model. This step is practically mandatory to truly validate your numbers before you dive into the deep analysis. To wrap up this explainer, I want to leave you with a bit of a provocative thought. We've just seen that the most sophisticated algorithms in the world cannot save you from the dirty data problem. So if incorrect data renders seemingly perfect models completely untrustworthy, how clean is the data driving the important decisions in your organization today? Are you taking the time to remove, fix, and filter? Definitely something we're thinking about. We're diving into something that literally dictates the success of every single modern business. We're talking about data cleaning and validation. Specifically, we're going to zero in on the final, absolutely critical steps of this process, handling missing data and quality assurance. Because as you'll see, getting this right has a massive, massive payoff. Let's jump right in. So, have you ever found yourself sitting in a completely uncomfortable reporting meeting, right in the hot seat, because the data you presented just could not withstand inspection? It's a professional nightmare, right? You're presenting these big company strategies, and then someone pokes a massive hole in your core numbers. The source points out a pretty harsh reality here. Making false assumptions based on inaccurate or dirty data leads straight to ineffective decisions. And honestly, it all stems from failing to properly clean and validate your information before you ever stepped foot in that room. Okay, let's look at section 1, the missing data dilemma, which is step 4 of the cleaning process. The source establishes a really strict technical reality right off the bat. Basically, missing data cannot be ignored. You literally can't just gloss over a blank cell because so many algorithms simply will not accept missing values. The system will just stop you right in your tracks and force you to make a decision on how to handle those gaps. So what do? Well, the source outlines 2 primary alternatives for handling missing data. And it's super upfront about the fact that while neither choice is exactly desirable, you absolutely have to explore both to avoid major errors down the line. Let's break them down. First up, alternative 1. You can drop the observations with missing values entirely. Just get rid of them. The big risk here? Doing that might result in the loss of incredibly valuable information. You really have to keep that in mind before you just start deleting rows. Then there's alternative 2. Entering those missing numbers based on other observations. But this comes with its own massive risk, right? There's a real chance that the data's integrity gets compromised, simply because any action you take might be based on assumptions rather than real, hard observations. It's a tough balancing act. You're constantly weighing the loss of information against the risk of compromised integrity. Moving on to section 2, interrogating your data. This covers step 5, which is validation and QA. At the conclusion of the data cleaning process, as part of your basic validation, the source insists you have to be able to answer 5 essential questions. Let's fire through these. First, A, does the data make sense? I know, it sounds almost too simple, but it's your ultimate reality check. B, does the data adhere to the regulations applicable to its field? Because compliance is totally non-negotiable. C, does it verify or contradict your working hypothesis, or does it shed any new light on it? D, can data patterns actually assist you in formulating your next theory? And finally, E, if not, is this due to an issue with data quality? Going through this checklist ensures you have that strict rigor, and it literally forces you to critically analyze everything you've put together before presenting it. Which brings us right back to this incredibly sobering quote directly from the text. False conclusions might result in an uncomfortable moment at a reporting meeting when it is shown that the data does not withstand inspection. If you skip those 5 QA questions we just went over, you are walking straight into this exact scenario. The source is crystal clear on this. Before you ever reach that dreadful point, it is absolutely essential to establish a culture of data quality inside your firm. That takes us to section 3, defining data quality, and establishing a culture of quality. Now, to actually establish that culture, we first have to clearly define what data quality means for the firm. And what's really interesting here is that it isn't just a generic one-size-fits-all metric. Determining quality actually requires analyzing the data's properties and then weighting those attributes based on what is most essential to your company and to the specific applications you'll use the data for. Basically, you have to customize your standards to fit your specific goals. But regardless of exactly how you weight them, the source outlines 4 main characteristics that make up the gold standard of quality data. We're looking at validity, accuracy, completeness, and consistency. If your data hits these 4 marks, you've built a rock-solid foundation. And more importantly, you're actively protecting your firm from those false assumptions and ineffective strategies we talked about earlier. All right, Section 4, the clean data payoff, boosting overall productivity. If you rigorously interrogate your data and establish those pillars of quality, you get the ultimate reward. The source notes that having clean data boosts overall productivity and gives you the absolute highest quality information for decision-making. We're talking tangible, systemic benefits here. You get error correction when numerous data sources are involved. You gain the capability to actually map out the many functions and planned uses of your data. You get improved error monitoring, which makes it so much easier to repair inaccurate or damaged data in future applications. And ultimately, using these data cleaning technologies will result in much more effective corporate procedures and significantly speedier decision-making capabilities across the board. But here's the really crucial point. This whole process isn't just about algorithms, databases, and corporate speed. There's a massive human element to this payoff. The source puts it perfectly. Fewer mistakes result in happier customers and less irritated workers. Think about that for a second. By cleaning your data, you are literally reducing frustration in the workplace. You're saving your team from the endless, mind-numbing headache of chasing down completely avoidable errors, and you're providing a way smoother, more reliable experience for your customers. Clean data protects your team's sanity just as much as it protects the bottom line. So I want to leave you with this final provocative thought to reflect on. Take a look around your own workspace. Are your company's decisions actually built on a culture of quality, backed by validity, accuracy, completeness, and consistency? Or are you kind of just acting on assumptions, guessing, and waiting for your next uncomfortable reporting meeting when the data inevitably falls apart?
You know, we're exploring a topic right now that sits at the very heart of literally any successful analysis. Yet, it's something that constantly trips up even the most seasoned data pros. We're talking about data validation. Whether you're out there collecting information in the field, evaluating deep analytical data, or just preparing to deliver final numbers to stakeholders, data validation is your absolute primary shield against total chaos.
So I want you to take a second and really ponder this crucial question. What is the most ignored stage in a data pipeline? You might be thinking it's something complex, right? Like maybe advanced algorithmic modeling or, visualization. But the reality is much more fundamental. Even though it's an absolutely essential stage in every single data pipeline, data validation itself is frequently ignored. It just gets pushed to the side, rushed, or sometimes skipped entirely.
So the crucial point here boils down to this classic, undeniable truth. Garbage in, garbage out. If your initial data is not valid, the outcome simply won't be accurate either. It's kind of like a fundamental law of data management. Using validation criteria to purify your data prior to usage is basically the only way to mitigate this problem. Ensuring data integrity right at the source directly contributes to the ultimate validity of your conclusions.
Let's actually look at what happens to you and your workflows when you decide to skip this step. Validating the precision, clarity, and specificity of data is essential for mitigating project failures. Without it, you run the very real danger of basing your strategic judgments on faulty data that's simply not indicative of the current situation. I mean, imagine presenting a massive strategic shift for your company based on numbers that are flat out wrong. That leads to severe project failures and, quite frankly, an incredibly uncomfortable moment when it's shown that your data doesn't withstand basic inspection.
Now, what's really interesting about all this is how our perspective on the process has completely shifted over the years. In the past, people had this old mindset. It appeared like data validation was just this unnecessary step that slowed down the work. But modern reality paints a totally different picture. Today, data validation can be accomplished considerably more quickly than we might have imagined even just a few years ago. With modern data integration systems that can actually include and automate these validation procedures, validation is now considered an integral, seamless part of the workflow, as opposed to some clunky additional step.
Let's move on and see how this builds into validating the actual data model.
Because, you see, in addition to validating data inputs and values, it is absolutely vital to validate the data model itself. Think about it. If the data model isn't appropriately constructed or developed from the ground up, you might encounter severe formatting problems while attempting to use your data files in various programs and software. The format and content of those data files will ultimately determine exactly what can be done with the data. A bad model literally limits absolutely everything you do downstream. So how do we actually protect ourselves? Enter the 6 shields of validation.
First up is the data type check. This verifies that the entered data actually has the appropriate data type. It sounds incredibly simple, right? For instance, a field might be designed to only take numeric values. If this is the case, the system must rigorously reject any data containing other characters, like letters or special symbols. Simply put, if you need a number, don't let anyone hand you a letter.
Next is the code check. This verifies that a field's value is picked from a legitimate set of options, or that it adheres to specific formatting requirements. A great example from the source material is a postal code. It's so easy to verify its validity by just comparing it to a master list of valid codes. The exact same principle applies to nation codes or Nike industry codes, which ultimately saves you from massive analytical headaches down the line.
And this brilliantly illustrates our third shield, the range check. This determines whether or not input data falls safely inside a specified range. Latitude and longitude, for instance, are frequently employed in geographic data. A latitude value absolutely must fall between -90 and 90 degrees, while a longitude value must fall between -180 and 180 degrees. If the system gets a value outside of this range, it's invalid, period.
Fourth, we have the format check. Numerous data kinds have to adhere to a set format to make any sense at all. The most popular use case here is date columns. Keeping dates in a fixed format, such as the standard 4-digit year, 2-digit month, and 2-digit day, is crucial. A data validation technique that aggressively ensures dates are in the correct format directly contributes to data and temporal consistency across your entire database. Shield number 5 is the consistency check. This is a form of logical check that verifies data has been input in a consistent, logical manner. Let's use a highly relatable scenario, checking whether a package's delivery date is actually logged as later than its shipment date. I mean, it defies the laws of physics for a package to be delivered before it ships, right? So your database shouldn't allow that impossibility to be recorded either.
Finishing off our rapid-fire sequence is the uniqueness check. Some data, like a PAN or an email ID, is entirely unique by nature. These fields should typically only contain unique items in your database. A uniqueness check essentially acts as a bouncer, guaranteeing that an item is not put into a database numerous times, which completely ruins your metrics and creates massive, annoying duplications.
So, we've covered the why and the how, which leaves us with this final, vital question. Is your next big project based on dirty data? Have you actually applied these automated validation shields, the type, code, range, format, consistency, and uniqueness checks to your own workflows? Because if you haven't, you're basically choosing to build your house on sand. Protect your insights, secure your pipeline, and start treating validation as the essential, automated step it truly is. We hear it absolutely all the time, right? Data is the lifeblood of modern business. But what happens when that lifeblood is, well, contaminated? Think of it kind of like trying to cook a 5-star meal with completely spoiled ingredients. It really doesn't matter how amazing your recipe is, the end result is going to be a total disaster. So today, we're unpacking the hidden costs of dirty data. We'll look at how tiny, seemingly harmless errors snowball into massive financial problems, and exactly how you can build a system to ensure your data is actually working for you. Okay, let's dive right into this with a very real, very relatable scenario. Consider a business that collects data on all of its regional outlets. Now imagine they neglect to do one incredibly basic thing, an appropriate postal code verification. Maybe a customer or an employee types in a zip code and just misses a digit, or maybe they just leave it blank entirely. It seems like a tiny oversight, right? No big deal. But what actually happens to the business's analytics when this one tiny piece of information is supplied incorrectly or simply left out? Let's take a look. The result is a totally chaotic domino effect. First off, without a proper postal code, just defining the location of the shop and certain mapping tools becomes seriously challenging. Next, you have to remember that a store's postal code is exactly what facilitates the generation of neighborhood-specific data. So without it, you completely lose those hyperlocal insights. Because of this, it's highly probable that your overall data simply loses its value. And the final blow? The financial cost. If that data needs to be recollected or the postal code needs to be manually input, further expenses will definitely be incurred. It's an entirely avoidable drain on resources.
So, when we contrast this massive problem with the actual solution, the fix is almost frustratingly straightforward. The core issue is relying on manual input errors. The straightforward solution? Providing a check that guarantees a valid postal code is entered. This kind of data validation is referred to as a code validation or a code check, and it's super simple to implement. The solution may be a drop-down menu or maybe an autocomplete form that enables the user to select a valid postal code from a pre-approved list. Just by forcing the data into a valid format at the point of entry, you completely eliminate all that downstream chaos.
To really understand how to manage dirty data when you've already collected it, let's look at a solved case from our source material. I want you to meet Maitreyi. She's working as a data analyst within a financial organization. Like a lot of analysts, she is supplied with a massive amount of data, and she plans to use statistical techniques for inferring some useful information and knowledge from it. But she quickly hits a wall. Before starting the whole process of data analysis, she finds out that the provided data is simply not cleaned.
Now, Maitreyi knows a fundamental truth of data science. Before applying any data analysis tools, cleaning the data is absolutely essential. You literally cannot just run complex algorithms on raw, messy data and expect to get reliable business intelligence out of it. If you feed garbage in, you're going to get garbage out. So smartly, she recognizes she has to halt her analysis and pivot directly to data cleaning.
And this brilliantly illustrates the exact roadmap that Maitreyi and really any successful data professional needs to follow to conquer that mountain of data. We're going to walk through the 5 key steps she should follow to clean the data: removing duplicate and irrelevant information, fixing structural errors, filtering unwanted outliers, handling missing data, and finally, validation and QA. Let's break these down.
Step 1 for Maitreyi is the removal of duplicate and irrelevant information. When her financial organization merges datasets from different departments, duplicate observations are practically guaranteed to happen. So she has to perform deduplication first. It's kind of like decluttering a messy desk before you can actually sit down to do some real work. Then she removes irrelevant information, stuff that just doesn't pertain to the specific topic she's analyzing. Doing this immediately reduces the noise and makes everything way more manageable.
Moving on to steps 2 and 3. Step 2 is fixing structural errors. When you transfer data, you often get unusual naming conventions, typos, or incorrect capitalization. She has to consolidate all those weird contradictions into a single clean category. Then, step 3 is filtering unwanted outliers. She has to hunt for extreme data points that just don't fit. Now, she shouldn't just delete them automatically, because an outlier could actually be a valuable new insight. But if it's clearly just a wrong data input, she filters it right out to keep her analysis on track.
For steps 4 and 5, Maitreyi has to handle missing data and then perform validation and QA. Missing data is tricky because a lot of algorithms literally just won't accept missing values. She has to make tough calls on how to handle blanks. Once she figures that out, she arrives at step 5, which is arguably the most critical phase of the whole shebang: validation and quality assurance.
This validation phase acts as a vital Socratic checkpoint. At the outset of this QA phase, Maitreyi should focus on answering a few specific rapid-fire questions to establish a real baseline of data quality. This is what prevents you from making huge decisions based on flawed info. So let's look at the 5 questions she absolutely must ask. Question 1. Does the data make sense? Well, it sounds incredibly obvious, I know, but you really have to take a step back and look at the big picture. If you're tracking regional sales and a tiny shop is suddenly reporting numbers larger than your corporate headquarters, logic dictates you need to pause. You have to ensure the numbers logically reflect the actual reality of the business. Question 2. Does the data adhere to the regulations applicable to its field? This one is absolutely paramount for Maitreyi, considering she's working in a financial organization. Financial data is heavily governed by strict laws. If the data violates any sector-specific regulations, it's essentially unusable, no matter how statistically perfect it might look on a spreadsheet. Question 3. Does it verify or contradict your working hypothesis, or does it shed any light on it? This is where the data really starts working for you. Remember, Maitreyi started with a goal to infer useful knowledge. The clean data should now be crystal clear, telling her whether the initial assumptions the business was testing are true, false, or maybe just a bit more nuanced than they originally thought.
Moving right along, question 4 asks, can data patterns assist you in formulating your next theory? Because clean data shouldn't just look backward. It should actively drive future business intelligence. The patterns that emerge here should spark new ideas and help the team formulate their next strategic moves.
And finally, the hard-hitting question 5. If not, is this due to an issue with data quality?
If the data isn't making sense, if it isn't shedding light on your hypothesis, and if it isn't helping you formulate new theories, you have to bring the entire process full circle. A failure here almost always points right back to a fundamental flaw in the original data quality.
After surviving this gauntlet, my tree finally achieves her goal. Let's zoom out to the macro level and define exactly what she achieved. Clean data. It isn't just a tech buzzword, it's information that has undergone rigorous verification and validation to ensure its absolute usefulness for analysis. It's data where the duplicates are gone, the logic is checked, and it's actually ready to generate real value.
So, the crucial point here is understanding the real benefits of clean data. The instructor in our source material highlights 4 distinct benefits, which we can call the 4 pillars of clean data. First, validity. Second, accuracy. Third, completeness. And fourth, consistency. When these 4 pillars stand strong, your data is uniform, it reflects real-world events, nothing vital is missing, and your business analytics are going to be rock solid.
Which brings us right back to where we started today. We've seen the incredible amount of work required to clean dirty data, and the immense value of having accurate, consistent information. So I'll leave you with this provocative thought to chew on. If your business analytics are failing to deliver the insights you actually need, is it a failure of your entire grand strategy? Or is it simply because, somewhere down the line, someone forgot to check a postal code?